Alright, here's a quick rundown of the solutions for the exam. So first question is a effective rate of interest. So in here what we've done is work out the total cost of the actual, the loan, which is the 10,000, 6 lots of $6 every month for 4 years. So you're effectively paying back $10,288. So you stick it into the formula to work out what your payment would be to get rid of that $10,288 in the 4 years, and you end up with $258.47. Then you take that, put it in as your payment, change your PV to 10,000, keep your N at 48, and work out what I is, and it comes to be 11%. So the effective rate of interest on loan A is going to be 11%. Next part says, the person decides to go for loan B. Well, loan B is 11.5%, and the effective rate on loan A is lower. So you'd go to loan A because it's cheaper in the long run. It's pretty cool. Okay, question 2, they're trying to save up money. So this is a future value question because the money is going to be in the future. Want to find out how much money they've got after 18 years if they're putting in $90 per quarter. So 18 quarters, 3.5% is your money. Payment is 90 or minus 90 as I've got it. And PV and CV, payments per year and compounding periods per year are 4. So you get your 8974. So not quite exactly what they want. So if they're going to keep the same payments up, how long would it take to get there? So you just take out N, keep everything else the same, and find out your new N, and you get 77.96 quarters, which is about 19.5 years. Okay. Then the next bit says if they put in more than $100 per quarter, show that they'll actually have the money on their 18th birthday. So you're trying to find payment here. Still, it's a future value question, so nothing else changes. 18 lots of times 4, 3.5 is I, PV is 0, payment you don't know, FV is 10,000, and you end up with $100.29. So the question says they deposit more than $100 per quarter, so you've shown that that is true. Next part of the question says what happens with the inflation. So now it's looking at the inflation. So it doesn't really matter which formula you use. I've just used this one, which is the compound interest formula. 10,000 is what your present value is. 1 add I, which is 0.023, because it's the decimal equivalent of the inflation rate, to the power of 18, and you end up with $15,057. So they're going to need a bit more money if they want to keep up with inflation. Describe one factor that inflects the reasonableness, that the rates remain the same, both the interest rates and also the, the inflation rate. If they go up or down, it's going to change your outcome. Okay, so if the inflation rate's high, they're going to need more money and those kind of things. Next one is a sinking fund question. How much interest will GI pay on the loan? Well, you got $8,000 is the size of the loan, 8.95 is the rate, 3 is the years, just simple interest question. So $2,148 is what he'll have to pay just to keep that loan at $8,000. So then he's got the sinking fund, which is a future value question. So he needs to get the $8,000, put in all the other gear like you normally would, and you end up with $206.43 that he has to pay every month into that loan. So he says, show that he saves approximately $570 by setting up the sinking fund. Well, it's $206 times by 36 is 9,579, and the $8,000 is the original loan. So you take that away, and it's $568.52. So it's about $570 he saves. Explain how J does that. Well, it's because you're earning interest on the sinking fund. So you're investing money, and as you're investing, it's accumulating. So therefore, it gets bigger and bigger, and hence you end up with more money in the end. So that's why that is like that. Cool. What's the next bit? I think I might have got the pages around the wrong way. I have got the pages around the wrong way here, sorry. So page 8. Maris takes out a home loan. They show that the minimum monthly payments are about $2,360. So it's a PV question because the PV is the loan. So PV is $328,000, I is 7.81, 30 times by 12, and PYCY is 12. So you get $2,363.45, which is approximately that. State 2 assumptions, that the rates remain the same and that they can actually afford the payment. There might be others there, but that's the 2 that I thought of straight away. Calculate the outstanding debt after 5 years. So I've done the PM1, PM2 using the amortization or the AMT button on your calculator. So you end up with a balance of 311,277.86. Okay, and then what they say here is, okay, at the end of the 8th year, let's assume that their balance is 297,635. They get 10,000 bucks. Take the lump sum off. Show me what the balance is. So you just go 297, take 10,000, and you get that. And then you go in to keep on finishing it off. So how many months will it take you to pay off the loan? I is 7.81, PV is that balance that you worked out before, present value is your payments that, future value is 0, payments per year 12, compounding periods per year 12, N is what you're trying to find, so it's 243 months. Okay, then it says how much interest will you pay. Now there's probably 2 or 3 ways of doing this. I just did it this way using the amortization. So I worked out the interest for the whole time, which is 522,840.66, using PM1, PM2 for the full 360 payments. So I went back to the beginning and reset the calculator. Then years 1 to 8, my sigma int was 196,525.21. And then years 9 to the end, once you put that lump sum payment in, was 284,560.09. Once again, using payment 1, payment 2, and finding sigma int in the amortization function of your calculator. And I got $481.85, Take that away from the original and you save $41,755.36. So it's a substantial saving. Part E says, is it kind of reasonable for this to happen? Well, not really. You've got to find that money as a lump sum, and not many people will find that money as a lump sum. Okay, so it's probably not realistic as a valid kind of saving kind of tool. What's another way of doing it? There's heaps of things. You could increase your monthly repayments. You could pay fortnightly. You could look for a cheaper loan, all those kind of things. But paying fortnightly or increasing your regular payments would pay that off. So there you go. That's that paper. I think it's pretty fair, and it should take you about, if you're doing this, it should be about 45 minutes worth of work. Okay. Cheers.